what are loss functions. Okay, guys. We'll do something that we were very young, when we were at least 14 years of age. Then we used to come across this term called partial derivative. We will quickly understand what is partial derivative. Just, one mathematical concept that we will revise. Now, guys, if I have an equation like this with you, 60 plus 2x plus 4y. Now, this equation, if I ask you to take a partial derivative, what does that mean? We want to know how much the function is changing with respect to only one variable. That means here, partial derivative means that this function, how much it is changing with only one variable, del f by del x or del f by del y. And to do that, what is the value of del f by del x here? Other thing would be treated as constant. So here your del f by del x will be, you will take del f by del x, you will take 60 and 4y both as constant, and your del f by del x will be equals to 20. Whereas your del f by del y, you will take these two constant and it will become 4. Does it make sense, guys? Let's do it again if it didn't make sense to some of you. What is a partial derivative? So partial derivative means how much this function is changing either with respect to x or with respect to y. And when you take that, you have to keep other things constant. Now, how much this function is changing with respect to x, you will take all these things constant and it becomes equals to 20. So your del f by del x here is 20. Whereas your del f by del y, when I do it, I take all first and second as constant and it becomes equal to 4. So this is how is the term partial derivative, where we have a function where there is more than one independent variable. And in that independent variable, I have to divide that independent variable and want to know what is how much my function varies with respect to one independent variable. That is my partial derivative, right? This is my partial derivative. How it is different from a traditional function? Traditional function was fx is equals to x square. And this fx equals to x square, it is only dependent on one independent variable. So the function was becoming is equals to, answer was 2x. Right? If you remember a little bit of differentiation. Right? So this is, here there is nothing about we can do about partial derivatives. Why we cannot do anything about the partial derivative? Because independent variable is only x. In partial derivative, we have two independent variable, x and y. Okay, very good. So this is how I understood. I hope you understood what is a partial derivative. Now on your screen, we have gone through this slide again, but we will do the loss function on the same problem so that we do not have any difficulty in understanding. Now we are inside one neuron and inside one neuron. So here, guys, we had three independent variables. We had age, we had exercise. So here we had age, we had exercise, and we had diet, right? And when I put them together into one equation, now my equation looks like this. Okay, somehow it has, okay. Hold on. Somehow it is. Okay, got it. So now you look on screen. Can you do this kind of thing here now? This was the equation here. Final equation was like this. This is happening inside your neuron. Now, del y by del x is your, if we do del y by del x, that means how much dementia is predicting with respect to age. So what will be the answer here of this equation will be 0.023, because rest everything will be constant in the equation, right? Now, how much this y is changing with respect to x2, which is your exercise? Your answer will be minus 0.053. Now, how much this entire function is changing with x3? Your answer will be 0.047. This makes sense, right? Because your initial problem was dependent on 3 parameters: age, exercise, and diet. So now I have a final answer, and I want to just know the variation with respect to one parameter. And I can do like this, right? Now, this is very important because here we are building an important concept, guys. Now, let us see here. On your screen now, I have now a data which was like this. It gave me finally, after plugging into each data set like this, it gave me 0.23, 0.47, and minus 0.53. And these are your weight 1 for parameter 1, weight 2, and weight 3. And you get this equation by simply taking the derivative of each, right? This is W3. These are the 3 weights that you get after taking the derivative of this entire equations with each of its parameter. Sorry, there's a typo here. This is your exercise and this is your diet. Yeah, this is a typo here. But this is how you're calculating, you're taking the weights out. Now, idea is, can I apply this problem to any problem? Now, instead of this data set, if I have a new data set to you, where I have here, I am predicting the price of the flight. And you can also tell me which of the activation function I will use. Now, I am predicting here flight price, and this flight price is here, which is your final answer. And this flight price, it depends on 3 things. One is the miles, like how far, of course, I am sitting here in Mountain View, California. If I have to go to Canada, I need bigger, it's very far, large miles, versus I just go here within US. It's a smaller mile. So mile is one parameter. Then airline brand, we know that is another parameter. That, if I am flying by United versus I'm taking some cheap flight like Spirit, my flight price will be low. Then, of course, I have a destination. Even if I go 5,000 miles towards Toronto versus maybe I'm going to some place in Hawaii, depending on the destination also, my price will differ. Now here your flight price is a problem of continuous variable. So first of all, you would not apply sigmoid function because your answer will not be 0 and 1. You will be applying here something like linear activation function. And then if I do this kind of, same thing and I start plotting, maybe I have an equation like this. Mile square air brand plus 2.5 into destination square. So any problem could be broken down into very simple steps where where if you take a partial derivative, you get the weights out, right? Okay. Now, this thing is clear to us. Main takeaways from here was understanding the concept of partial derivative. Then the other takeaway was the same problem could be applied to any problem, the same schematic. And I've applied it for you here on the flight price. And this is the value I get. Now, it's getting little complicated from here. Okay. Now you look here. Now what I did here is, I am trying to tell you what is a loss function. Now this is, we have understood it thoroughly, right? No problem here. Now I gave you a new patient. So, or right now your data is getting trained. We are still in the training phase. Now in the training phase, when we were training it, our answers, for example, they were not coming. This is your ground truth, guys. This is the data from your, this is your ground truth. This was the data that was given to you by the hospital. So this is known as ground truth. Now, you are training the model so that it can predict exactly as ground truth when used on training data. And when it is a test data, that is a new patients coming in, based on how it was trained, it should be able to give you the right answer. Now, what happens is while training, now this equation was like this. So point is, how does a neural net, it reaches to these final weights? How it is happening now? I was doing it mathematically, but how does it happen in the neural net? This is what is the procedure, and there we will learn about loss function. Now, when you start this problem, you start with your initial weights as 1, 1, and 1. This is known as weight initialization. And you also put the bias equals to 0. And your initial neural net is like this. And when you start training it, you do the same steps. You know this is the equation of neuron. This is inside, when you call your model, and you have a sigmoid function. Now, what does it take? For example, your thing here. Now, I am taking for the age 1. Look at the first row here, 23, 1, 1. So I am putting 23, 1, 1 into the equation, which is this equation. And look, my answer is 1 into age, 1 into exercise, because here I had 1, 1, 1. So this was, my neural net has started training, and my answer is 0.056. That means your predicted Y. And your actual answer is ground truth is 0. So this, whenever you use Y hat, you see here there's a Y hat. This is 0.56. This is the predicted value. And Y0 is your ground truth. The error that you have is minus 0.56. Right? So what I am trying to tell you is what is the loss and what is the error. So when your neural net start training it, it is on the first row now. And on the first row now, it tries to start with the weight 1, 1 here. It did not, this is the weight that we know, these are the correct weights. But when the neural net starts, it starts with 1, 1, 1. It tries to plug into this one here. And you get a value which is 0.56, where your ground truth is 0. Then what is the error between your ground truth, which is your 0, versus this is your predicted value? It is minus 0.56, right? And if you plot this thing, now if you plot this thing on this curve here, you see that your curve looks like this. This is a lot of error here. What the idea is to minimize this error. So this error, now let us see how do we get to this final good curve inside the neural net. Okay. Now imagine for the row 2, because neural net is going from, it is going through the entire data set. Now neural net is going through entire data set. Now for the second data set, when you start training it, you get, this is your predicted value 0.036, whereas your answer is your 0, and this is the second data set. So your error is minus 0.36. Okay. Now it goes on the third one. So it is like the code that you wrote yesterday. When you train it, this is what is happening. The neural net, it starts with your initialization weight of 1, 1, and 1 and bias 0. And it starts training the model. It starts trying to find the relationship between your input parameter and the final y. Okay. Now, for row 3, it is also predicting the error, that is ground truth, which is 1 minus your 0.56 was the prediction. So answer is minus 0.26. So now there is a lot of error, right? At every data set, there is a lot of error now. So it will keep on going from this, and will keep on giving me these error values. Now what happens? How does your neural net know? So when neural net has gone through all these errors, there is something that we call as, so this is a very common term that you will come across, is a cost function. So this is your loss function, and then it becomes your cost function. So when you try to integrate error and you try to add all the errors in the data sets, this becomes your total error. And this is something that you understand it separately. If I today try to give you a problem and try to develop neural net on that, you will have an error related to each data set. So if your data set was 20 spam emails, your data set will, your error will be respect to each of these data sets. So that is your error 1, 2, 3, 4, and depending upon how much data set we have. And you can have again different errors. What does that mean? This means this is your predicted value and this is your ground truth. And you try to take the difference. And now this should automatically make sense to you that we are trying to minimize this difference. And for that, we use an optimizer. And this difference, that is of the predicted value with the ground truth, it can be represented as mean squared error, which is here, and which can also be defined with your absolute error, which will be here. Now let us see how many types of errors, your loss functions we can have. So guys, these are the common loss functions, and you have seen in your first slide that I showed you, and I will bring that slide again. When you write the code, you come across binary cross entropy, you come across categorical cross entropy, you come across absolute error, squared error. And this is, remember your model.compile when you write the code and you have the optimizer and you choose a error. One is your mean absolute error, which is simply y hat minus y. And you sum it. This is a summation here. And this is your mean absolute error. This is a little bit of math here, absolute error. You know, it will take mode of that. Then you will have something called mean square error, which is here your y minus y hat square. That is your mean squared error. So the errors, the difference can be plotted into different functions, because ultimately after plotting this difference, we are trying to optimize it. Depending upon, you know, the optimizer, how it will behave, we have to, you know, plot these errors. So on your screen here, if you see, normally what I told you about is the absolute error, where y minus y hat is your mean absolute error. It is plotted here like this orange curve. It's a straight line, we know, y minus y hat. Now, when it becomes your square, we try to give it a shape. So you see MSC, squared ones looks like these curved lines here. This is your square error. Now there is also other ones like Hubbard, and these ones are not important, but people try to say like they are even better. But for your beginning, you know, understanding, it is good to know you have absolute error, squared error, and other two errors that you have to keep in mind is cross-entropy and categorical cross-entropy. I would not get into detail into it, but these words are used especially when you have, you know, a binary classification problem, and it is based on a lot of probability. So the idea is we are trying to plot this error into different functions, right? So now this thing should be clear to you. Your predicted versus ground truth has a difference for the model when you start training it, right? And somehow you plot this difference, and this is your loss function, right? Or error function. Now tomorrow I come and I ask you, please let me know which error function you want to use, or which loss function you want to use. So you can talk about mean absolute error or mean squared error, right? Okay, very good. Now is the last concept, guys. This should be very much clear to you, because this is a four line of code, and if you do not understand, you know, what is the meaning of each line in the code, then you haven't understood how, you know, the entire system works.